Okay, so we find ourselves working with solving radical equations. When the radical is present as soon as we start, it's a whole lot easier to just jump in and say, okay, well, I'll square both sides, or I'll cube both sides to get rid of the radical. When we're dealing with a rational exponent, we need to acknowledge the fact that we have no access to that x buried inside those parentheses until we make that exponent 1. We do this by, again, isolating the term that we need to work with, so we'll divide by 2 first. And then we need to acknowledge the fact that one of those exponent properties we have, when we raise a power to a power, we multiply the exponents. So a power of 2/3, if I raise it to the 3/2 power, the reciprocal of that exponent, I will have an exponent of 1. Now I need to do this to both sides, so 4 will also be raised to the 3/2 power. On the left side, I need to acknowledge that I dealt with an even root on the way through. If either the numerator or denominator, either one of these values is even, I'm going to need to work with absolute value. And on the right, I'll just evaluate what I've got. 4 to the 3/2 power, that's 4 cubed, and then I take the square root, I get 8. Now I don't need to worry about plus or minus because absolute value is going to take care of that. Splitting that up, x plus 3 is 8, or x plus 3 equals -8. Okay, x equals 5, or x equals -11. Now, being the conscious of all of my surroundings student I am, I will need to check my work. We go back to our original equation. Instead of an x, we'll replace it with 5. Step by step, we'll evaluate what's there. Turns out 8 equals 8, we're in good shape. Looking at the other solution. I replace x with -11. The cube root of -8 isn't an issue. I just get -2. When I square it, it becomes that same 4. 2 times 4, 8 equals 8. Both those solutions are completely valid.